Welcome to another MDX Tutors video. Remember that if you want to get private tuition on maths, science or English, you can contact us to get in touch with the best tutors in the UK who are experts in our field. In this video we're going to talk about simultaneous equations. In particular, it will be focused for higher papers. However, the first part, when we deal with linear simultaneous equations, can also be useful for those of you in the foundations. What are simultaneous equations? They are two equations that have the same unknowns, and the solution that we find for each of those unknowns has to satisfy both equations simultaneously. The reason for this is that we can draw a graph for each of the equations, and the solution will be the intersection point for the two plots. For example, if we have these two equations, x plus 2y equals 4 and minus x plus 4y equals 2, here the unknowns are x and y, we can plot each of these equations as functions of x and y. This will give us the following graph. And so, looking at the plot, we can find very easily the solution for the problem, because if the horizontal axis is the x-axis and the vertical one is the y-axis, we know that this intersection point has x-coordinate 2 and y-coordinate 1. So this point is the point 2, 1, because remember that the first coordinate was in x and the second coordinate was in y. And so we know that the solution to this problem will be x equal to 2 and y equal to 1. And actually, if we plug in these two values in the equations, both of them should satisfy them. Let's check that. Let's call this equation 1 and this equation 2. Now let's replace the value of x and y in equation 1. We have x plus 2y, so that is x equals 2 plus 2 times y equals 1. And this is equal to 2 plus 2. 2 plus 2 is equal to 4, and so this equality is verified. Now doing the same for the second one, minus x is minus 2 plus 4 times y, that is 1. This is minus 2 plus 4, which is equal to 2. And so again, this equality is verified, meaning that this is the solution to the problem. But how do we actually get to these values without looking at the plot? Well, let's see how we can solve this. When we have two linear equations, like in this case because all the variables have power 1, the method that we will use is called elimination. Elimination consists of eliminating one of the variables to only have dependence on the other one, and then just solving a simple equation will give us the final answer. The solution that you will get if you eliminate x or y will always be the same, and so just choose the variable that you want to eliminate depending on which one will be easier. In this case, for example, we see that we have 1x in the first equation and minus 1x in the second equation. So I know that if I add these two equations, then x and minus x will cancel out, leaving me only with an equation that depends on y. So let's write that down. Let's call this equation 1 and this equation 2. Now, if we do 1 plus 2, what we get is x plus 2y equals 4, and I have to add minus x plus 4y equals to 2. So I can add all these things. The signs, because we have addition, will not change. And this gives us x minus x, which is 0. 2y plus 4y is 6y. And then 4 plus 2 is 6. So I have now that 6y is equal to 6. And so dividing by 6, we get that y is equal to 1. But this is not everything. Now we also have to find the value of x. And once we have one of the variables, substitute to find the other one. In this case, the other variable will be x. And a question that's very common at this stage is, in which of the two equations do I have to substitute? Well, it will be the same, because the solution has to satisfy both equations. So just pick one and substitute into that one. Let's choose the first one, for example. So we will have x plus 2 times y, and y is equal to 1, equals to 4. This is x plus 2 equals to 4. And so we can move these two to the other side with a minus sign, and we get that x is equal to 4 minus 2. And so x is equal to 2. So our solution is x equal to 2 and y equal to 1. If we go back, we see that it's the same solution that we had directly from the plot. Now let's solve by elimination these other equations. Let's try now to eliminate y. So we have to pay attention to this column of the equation. For this, what we usually do is multiply the lower equation by the coefficient in the first equation and the first equation by the coefficient in the lower equation. What does this mean? Well, let's first give these two equations some names. And now we will multiply equation 1 times 5, the coefficient in the second equation, and equation 2 by the coefficient in the first one, in this case, times 2. The first one will give me 3 times 5 is 15x, plus 2 times 5 is 10y, and 4 times 5 is 20. The second one, times 2, will give me 4x times 2, 8x, plus 5y times 2 is 10y. 17 times 2 is 34. So now we see that we have the same coefficient here. But if we add these two equations, we will get 10y plus 10y, that is equal to 20y. We want to get 0. This tells us that we have to subtract the equations. When we subtract, remember that this minus sign is applied to all the second equation. So we have to change all the signs in here. So let's do this calculation. 15x minus 8x is 7x. Then we have 10y minus 10y, that is 0. And then we have 20 minus 34, that is minus 14. And so if 7x is equal to minus 14, dividing by 7, we get that x is equal to minus 2. And now, like before, we just substitute in another equation. So substituting x equal minus 2 in, for example, the first equation, we get 3 times x, so 3 times minus 2 plus 2y equals to 4. 3 times minus 2 is minus 6. And now if I add 6 on both sides, I get 2y equals to 4 plus 6 is 10. So y dividing by 2 is equal to 5. This tells us that the solution was doing x equal to minus 2 and y equals to 5. If we now look at the plot of these two functions, this is the intersection point, and this intersection point has x coordinate minus 2 and y coordinate 5. So this is the point minus 2, 5. And that is exactly the same that we had for our solution. This shows us that the exercise is solved correctly. Now let's solve this other equation. Let's again focus on eliminating the y variable. But remember that if you choose to eliminate x, you can still reach the same solution. Let's name the equations 1 and 2. And again use the same method that we had. We will multiply the first equation by the coefficient in the second one, 4. And we will multiply the second equation by the coefficient in the first one. In this case, the coefficient is minus 1. But let's just multiply it by 1. That is just keeping it the same. So let's ignore the sign that this coefficient had. The first equation multiplied by 4 will give us 3x times 4, 12x, minus y times 4 is minus 4y, and this equals 4 times 4, 16. The second equation multiplied by 1 will just keep it the same, 2x plus 4y equals to 26. So now if we look at the y terms, we have minus 4y plus 4y. This shows us that if we add these two equations, we will get 0y, and that is exactly what we want. So let's add these two equations. 12x plus 2x is 14x. Minus 4y plus 4y is 0. And 16 plus 26 is 42. So we have 14x equals to 42. And if you are good at mental math, you can see that x will be 42 divided by 14, which sounds weird, but it's actually equal to 3. Now we substitute x equals 3 in the first equation. You could do it in the second one. And we get 3x, so 3 times 3 minus y equals to 4. This is 3 times 3 is 9 minus y equals to 4. So if I move this one to the other side and the 4 to this side with a minus sign, I will get that 9 minus 4 is equal to y. 9 minus 4 is 5. And so that is the value of y. So the solution is going to be x equals to 3 and y equals to 5. Again, if we plot these two equations, we find that the intersection point has x coordinate 3 and y coordinate 5. So this is the point 3, 5, and that is exactly what we got in our solution. Now let's solve this other equation that can be a bit more complicated because it has bigger numbers. Again, let's eliminate the y variable. Let's call this equation 1 and equation 2 and do the same that we did before. We multiply 1 by 2 and we multiply 2 by 5. Equation 1 times 2 gives me 3x times 2 is 6x minus 5y times 2 is 10y equals to minus 31 times 2 is minus 62. And now multiplying the second one times 5 is 4x times 5, 20x. Minus 2y times 5 is minus 10y. And then minus 18 times 5 is minus 90. And now we notice that we have minus 10y minus 10y. So if we add these two equations, we would get minus 20y. But if we subtract them, we would get minus 10y minus minus 10y, and that is minus 10y plus 10y, which is equal to 0. And that is exactly what we want. So let's actually subtract them, remembering that when we subtract, we have to change all the signs. And now we will have 6x minus 20x. This is minus 14x. Minus 10y minus minus 10y is 0. And minus 62 minus minus 90 is minus 62 plus 90. And this is 28. So we have minus 14x equals to 28. So x will be dividing by minus 14 minus 2. Now let's replace in the second one. 4x is 4 times minus 2 minus 2y equals to minus 18. 4 times minus 2 is minus 8, and then minus 2y equals to minus 18. So moving this minus 8 with a plus sign to the other side will give me minus 2y equals to minus 18 plus 8 is minus 10. And then dividing by minus 2 gives y equals to 5, because minus 10 divided by minus 2 is positive 5. So the solution will be x equals to minus 2 and y equals to 5. Let's look at the plots of the two equations. Again, this is the intersection point, and this intersection point has s coordinate minus 2 and y coordinate 5, meaning that this is the point minus 2, 5, which is equal to the solution that we just got. Here are some more exercises for you to practice. Let's see very fast what we should do to solve them. Let's name the equations. And then here, let's say we want to make x disappear. We would have to do equation 1 times 4, equation 2 times 3, and that would give me 12x and 12x. So to get 0, we would have to subtract them. In this one, equation 1 and 2, let's eliminate y because it has smaller numbers and opposite signs, so it will be easier. For that, let's multiply equation 1 by 2 and equation 2 by 3. And this will give me minus 3y times 2 is minus 6y, and then plus 6y. So I will have to add them because the first one is already negative. And so if I subtract them, I would get minus 6y, which is 12. So just add them and that will give me 0. For this one, equation 1 and 2, let's say that again we want to eliminate y. Then we multiply equation 1 by 3 and equation 2 by 1, so just keep it the same. This will give me minus 3y in equation 1 and minus 3y in equation 2. Minus 3y is minus 6y, and that shows me that I will have to subtract them because they have the same sign. So this will have minus 3y minus 3y, that is plus 3y, will give me 0. And finally, let's name these two equations and try and eliminate x. Because notice that if I take equation 1 and just subtract equation 2, I'll have 3x minus 3x, and that is 0, showing me that I can very easily eliminate the first variable. So just doing equation 1 minus equation 2 will make x go away and solve for y. With this we finish the video, but remember that if you require more assistance, be it in math, English or science, the key stages, GCSE or A-level, you can always contact us via Instagram, Facebook or on our website to get private lectures by experts.